Welcome to our lesson on differentiation. Today we'll be talking about introduction to the quotient rule. So when do we apply quotient rule? Quotient rule is needed when a function is dividing another function and we are asked to differentiate. All right. So consider this. Say y is equal to u over v, where both u and v are functions. All right, so you'll be asked to differentiate, that is, look for the first differential, which is dy dx. Now, since you have two functions that you are differentiating, we use this formula. What does this formula mean? The formula means that first, keep the denominator, okay, and differentiate the numerator. So the denominator is v and then the numerator is u. So you keep the denominator and then you differentiate the numerator. Minus, now you keep the numerator and then you differentiate the denominator. That will give you dv dx, all divided by v squared. Okay, so we will practice an example for us to see how this is done. So we have a function which is giving us 3x plus 2 all over 4, x plus 4. Now our job is to find dy dx. So how do we start? We let the numerator be what? U, and then the denominator be v. The formula says we should look for du dx and then dv dx. Hence, we will have to differentiate this u with respect to x. That will give us du dx, and also we will differentiate v with respect to x, and that will give us dv dx. All right, so du dx will be the differential of this function, and that is 3. And then dv dx will also give us 1, because when we differentiate x, we'll get 1, and the differential of a constant is 0. Okay, so still working on this function, we quote the formula. Okay, we quote the formula and then we substitute the values. We said that the numerator is u and then the denominator is v. Okay, so we are going to keep v, so we will keep v, so we will write the v, which is x plus 4. Okay, and then we will differentiate the numerator, which is u. When we differentiated it on our previous slide, we got 3. Okay, so that is it. The dot here means times, so we multiply by 3. Okay, because this and that are multiplying, v and du dx are multiplying. Then we bring the subtraction sign. Now we have to keep u. What is u? U is the numerator, 3x plus 2. Okay, and then we multiply it by what? Dv dx. But dv dx is the differential of the denominator, and when we differentiate the denominator, we get 1, like we got on our previous slide. All right, all divided by the denominator square, which is x plus 4 all squared. Now our job is left with algebra. Okay, because what we have done here is the calculus, is the differentiation. The rest is our algebra. So we will expand this bracket and expand that bracket and simplify. All right, so when we expand, 3 times x give us 3x, 3 times 4 will give us 12. Then 1 times this whole thing is the same thing. Okay, but negative times 3x will give us negative 3x, then negative times 2 will give us negative 2. All right, so 3x and then 3x and negative 3x will cancel out. You get 0 there, and then 12 minus 2 will give us 10. Okay, over x plus 4 all squared, and you are done. Right, so like I said, as soon as you get to this level, you are done with calculus. The rest is algebra. Another example, we have y is equal to x squared all over 5x minus 2. Our job is to find dy dx. So the first step is to define them. let u and then v be equal to these functions. So let u be equal to the first one, and then let v be equal to the second one. Then our job, our formula says we should look for du dx and then dv dx. So we have to differentiate u and v respectively. Now, if we differentiate this, we will get du dx giving us what? 2x. And when we differentiate this, we get 5. So our job is to substitute u du dx, v dv dx into this formula, and then we are done. All right. So when we substitute, we have v first, right? So this is v. We keep it here. Then we have times what? Du dx. What is du dx? It's 2x. This is it. Then we have minus. So we bring the minus sign. Followed by what? Followed by u. But what is u? U is x squared. So this is our x squared. Times what? Dv dx. What is dv dx? That is 5. This is it. So now we are done with the calculus. We are left with what? Algebra. So let's expand. 2x times 5x will give us 10x squared. Then 2x times negative 2 will give us negative 4x. Then we bring the subtraction sign here. 5 times x squared will give us 5x squared. So this is what we have. But now consider this. 10x squared minus 5x squared are workable, right? So we subtract and then we have 5x squared. We are left with what? Minus 4x. This is it. Now x is common to both, okay? So we factor x out and then this is what we have. We are done. All right, you should try this. So you work this thing out and your final answer should be this. Okay. So how about when the numerator is having a square root sign? How do we go about it? It works with the same principle. I would advise you to always quote your formula. It will help you to know what you are doing. So let u be equal to the first one, okay, and then v be equal to the second one. So u is equal to the first one, but root of x means x raised to the power 2. All right, it is nice to write it in index form so that the differentiation will be simple for you. Now we differentiate du and then we will get this. So look, this is it. The power comes down, so the half comes down. Then you have x, then you subtract 1 from the power, and half minus 1 is negative half. Then we have v to be equal to this. So dv dx will be for us to differentiate this with respect to x, and then we will get 2. Now our job is almost done. What we need to do is to input u at where u is, v at where v is, du at where du dx is. So that's it, and we are done. Basically, dv dx is 2, so we put 2 there. So I just had to quote these things again so that you wouldn't have to go to the next slide to understand. Okay, so now let's do the input. So we put u at where u is, and then we put v at where v is. All right. Okay, so u is here, then u here, we keep it here, okay, and then the v will also follow. Then we have du dx, which is here, and then dv dx, which is there, all over v squared, and this is v squared, right? So like I said, you do basic substitution. At this stage, our calculus or differentiation or quotient rule is done. The rest is algebra. All right, the rest is algebra. Now I want you to pay attention here. Now we are going to expand this bracket, okay? So half times 2, okay, will be 1, and then this is x raised to the power 1, and this is x raised to the power negative half. So that will give us x raised to the power half. Then we multiply half x raised to the power negative half by 1, and then we will get the same thing, right? Then 2 times this will also give us 2x raised to the power half, all divided by 2x plus 1 all squared. Now this is what you should do. You see, there is x raised to the power half here, and then we have negative 2x raised to the power half. They are like terms, so we can simplify. All right, so that will give us negative half raised to the power x. But if you have half x raised to the power negative half, with the help of indices, we can write it as 1 over 2x raised to the power half. Okay, now this is what I want you to do. Solve the numerator separately before you deal with the denominator. Let's go to the next slide to see how to go about it. All right, so like I said, this is what we got on our previous slide. Okay, so we are going to solve the numerator separately. Now every whole number is over 1. Okay, so we can say that this is over 1 like this. All right, then divided by, you see all divided by this, we will keep it separately. Why? Because it will help us. Of course, if your level of algebra is strong, then you might have another way or a better way to go about it. All right, so how do we go about this? The LCM of this is 2x raised to the power half, isn't it? So this is how we go about it. Now the LCM is this, okay? It's the same as 2x raised to the power half, but this 2x raised to the power half will go into 2x once, okay? So 1 times the numerator 1 will give you 1. Now this will go into the numerator 2 raised to the power 2x raised to the power half. All right, now 2x raised to the power half times the numerator will give you 2x. Why? Because we understand that the 2 must be there, no problem, but the x, this is x raised to the power half times x raised to the power half, that will give you x. All right, others want to think of it this way, cross multiplication. So they will say 1 times 1 is 1, and then 2x raised to the power half times x raised to the power half will also give you this, all over this times that, and that is what we have. That is also a better way to explain the concept. Then we know that since this is dividing, we will have to reciprocate it, and then we multiply, and that is what we do. Okay, so now 1 times this times that. All right, and what do we get? This is what we get. Now someone might ask, we are supposed to have 2x raised to the power half times 2x plus 1 all raised to the power 2. So why do we have the square root? Well, x raised to the power half is the same as the square root of x. Okay, all right. How about when you have this, where the square root is affecting the denominator? All right, so if the square root is affecting the denominator, then right, so we let u be equal to the numerator and then v be equal to the denominator. All right, now I always want to set up my function in the exponential form, okay, that of the indices. Why? Because it helps me to differentiate well, and like I've been telling you, the square root stands for half, okay, a power of half. All right, so we differentiate them. We differentiate du, we get 1. We differentiate v with respect to x, and this is what happens. Look, you differentiate, this is a chain rule. Remember that it would work applying the chain rule. So instead of quoting the chain rule formula and then differentiating, there's a better way. What do? Differentiate the outer function. That is, half will come down, okay? Then you write the entire function. Then you subtract 1 from the power. And this is what you have, right? You have this. Times, then you go inside the bracket and differentiate, all right? So when you differentiate what is inside, you have -2. For more videos on quotient, chain rule differentiation, check my playlist. Okay, you will see it. I've covered that lesson already. All right. So what do? We clean it up. Now look, if you have half multiplying -2, that will become -1, okay? So that's the negative sign here. Then this is what we have here, right? So we can just go straight away and then we would substitute into the formula. The formula says that v du dx, okay? So what is v? This is v, okay? So v is here, du dx is 1, okay? Then we have minus, this is minus what? It says minus u, okay? But what is u? This is u is x, and this is what we have here, this is u, okay? Times dv dx. But what is dv dx? This is dv dx. Remember that dv dx is also coming with a negative sign. That is why you are seeing two negative signs here. But negative comes into contact with negative to produce what? A positive, and that's what we see here. All right. So this times 1 is the same thing, and then this gives us what we have. Just I decided to bring the x in front. Okay. That's it. I have not done any other thing. All right. So what do we do? Like I've been saying, as soon as you reach this level, you are done with the differentiation you are doing. The rest is algebra. The rest is algebra. And I would advise you to solve the numerator separately, after which you can add the denominator in the calculation. Okay, so this is where we ended on our last slide. Let's see how to go about that. All right, so we want to solve the numerator separately. So we have half plus, we have x. But remember that when you have 1 minus x raised to the power -1/2, indices will tell you that this can be expressed as x over 1 minus 2 or raised to the power half. Okay, so that is what we are going to solve. Of course, the denominator is there, which I have represented as divided by 1 minus 2x. It's okay. Keep it there. Don't touch it. Let's focus on what is happening here. Okay, so the best way to go about this is to multiply this by that. Remember, this is the same thing here. So when you multiply this by that, you will get the same thing, and then the power will be added. So half plus half will give you x. I'm sorry, half plus half is 1. Okay, so this is what we have. 1 minus 2x all raised to the power half times 1 minus 2x all raised to the power half will certainly give you 1 minus 2x. Okay, then this is over 1. Okay, so that 1 times the x is still x. All right, then you multiply the denominators. So this over 1. So 1 times this is the same thing. All right, now we can touch on the denominator. Remember, it is dividing, so we reciprocate it and then we multiply, and that becomes 1 over this. Okay, times, no problem. So this 1 minus 2x plus x, minus 2x plus x will give us minus x. All right, then the 1 is there. This multiplying it doesn't change anything. Why? Because 1 times any number is the same number. Now this has a power of 1 and this has a power of half. So it becomes 1 minus 2x raised to the power 3 over 2. Alright, so in our next lesson, what shall we look forward to? We shall look forward to solving more examples on quotient rule, okay, specifically word problems. Alright.